Yeah, so okay, good evening, everyone. Uh, Today is the fifth sessions of our tutorial sessions. Okay, so this times I will be talking about yeah, some time-dependent perturbation problems, as well as I will also solve the remaining two problems which we left last week. Okay, so I will start first with the last assignments. Okay, not this week assignment, the last week assignment which I have not yet finished. Okay, the last questions was, I mean, the last question is related to your harmonic oscillator. Okay, and it is given that the question it is given that for a harmonic oscillators you have an operator a cap as also an a cap dagger. Okay, so I hope the assignment question is already there with you. I will not write it here. So a cap and a cap dagger, and it's also given that your x cap operator is given to be h cross by 2 m omega a cap plus of a cap dagger. Similarly, your momentum operator also p cap is given to be I m omega h cross divided by 2. Okay, m omega h cross divided by 2 a cap dagger minus of a cap. So let me just repeat whatever I have been saying. Okay, so this today we will be talking about these the week assignment, that is the week 5 assignment, and also I will finish the last two assignment which I have not yet to finish. Okay, so if you look at the question number 5 from the week 4 assignment, they were talking about the harmonic oscillator, and it's given to you that the position operator is given to you as well as the momentum operator is given to you. And what is the question? The question is that you have to find the expectation value of this states. Okay, 0 x 0, this is 0 is a ground state, 0 the momentum operator, and square operator, as well as your p cap square operator. Okay, so these we have to evaluate. This is from the week 4 assignment. Okay, so before I solve the problems, let me just write the formula that we are using, or the terms that we are using in these problems is operator operate on the state n is any states, is given to be n minus 1. Okay, a cap dagger operate on the state n, it will be given to root over of n plus 1 n plus 1. Okay, then a cap operate on the state 0, it will be equal to 0, and n m is a delta mn. Okay, so these are the formulas that we are be using. So this is a pretty straightforward. Okay, so it is given to you, x cap is given to you, p cap is also given to you. So we'll first start with the first expectation value, which is the x cap expectation value. Okay, so what does it means? You just substitute the value of x cap here. So x cap is already given to, x cap is equal to root over of h cross by 2 m omega a cap plus of a cap dagger. Okay, so now what we have to do, I can take it out, h cross by 2 omega outside because it's a constant term, right? And then I have 0, x cap will be a cap plus of a cap dagger and 0. Fine, so now you just x cap by root over of, sorry, so this will be square root. Okay, so here also will be square root h cross by 2 m omega, then you will get what, 0 a cap of 0 plus 0 a cap dagger of 0. Okay, so if you use the formula which I have given it to you, this one, a cap dagger of 0, it will be 0 plus 1 root over of 1, right? You just substitute, instead of n you just substitute 0. So what happens is that these will get what, h cross by 2 m omega, this term a cap of 0 will go to 0 plus a cap dagger of 0 will be 1 root over of 1, correct? So you will get what, you will get 1 here, sorry, not 1, you will get 0 1, correct? Because a cap dagger of 0, it will be equal to 1. A cap dagger of 0 will be equal to root over of 1 state 1. Okay, so these terms 0 and 1 again, m n is equal to delta of mn. So if m and n are the same, then you will get 1, otherwise you will get 0. So this term also will goes to 0. Then the whole of expectation value of the ground state of a harmonic oscillator is equal to 0. Okay, so the first term is done. Now what is the second? The second is 0 p cap of 0. Now if we have to find the momentum expectation value of a ground state. So similarly here also we will write the same thing, right? So you put the value of p cap. P cap is already given to you in the question. You get I m omega h cross by 2 and then 0 a cap dagger minus of a cap 0. Okay, here also you will get the same thing, I m omega h cross divided by 2. So you will get what? You will get 0. Again, a cap of 0 you will get simply 1 minus 0 a cap of 0. Correct? You just need to split this one. A cap, that means you just multiply a cap to 0, a cap dagger, and also this one to 0. Okay, that means you operate a cap dagger on the state 0 and a cap on the state 0. So again, this will equal to 0, 0 and 1, and here also a cap of 0 will equal to 0. The final value of the expectation value is also equal to 0. Okay, so the expectation value of both position and momentum in the ground state is equal to 0. But another question is asked to you, what is the expectation value of x square? Not simply x, but x square and also p square. Here also what you need to do is the same thing. Okay, so what is the value of x cap square now? It will be simply multiplication of x cap into x cap will be equal to simply h cross squared by 2 m omega a cap dagger plus a cap whole square. Okay, now we have to do the same thing. So what is happening now? So you can calculate h cross by 2 m omega, okay, a cap dagger square plus a cap dagger a cap plus a cap dagger plus a cap square. We just need to expand this formula, a plus b whole square. So now here also is importance, some formula, a cap comma a cap dagger equal to 1. Also a cap into a cap dagger will be equal to a cap dagger a plus 1. Okay, we might be using this sets of formulas. Now you already know what is the value of x square, which is given by this value. So what is the expectation value? 0 of x cap square 0. It will be equal to h cross by omega. You take it out because you don't need to do that. I mean, you don't need to solve. So you get 0, and x cap square you put this value. So you'll get a cap dagger square plus a cap dagger a cap plus a cap dagger plus a cap square, operate on the state 0. Okay, so again here also you just what you have to is that you have to multiply a cap, or you have to operate in other terms, this to this term, this to this term, this to this terms, and so on. So if I want to expand this one, you will get h cross by 2 m omega, you get 0, you will get a cap dagger square 0 plus 0, then a cap dagger a cap, operate on the state 0 again, plus again 0, you will get a cap dagger on the state 0 plus finally 0 a cap square 0. So these problems is what you just need to expand. So now you have to solve each terms. Okay, so a cap dagger of 0, what will happen? This will happen. What will happen to all these 4 terms? Okay, so whatever the formula which I have given, a cap dagger square, that means you perform 2 times a cap dagger operator, simple as that. Okay, so whatever the formula which I have given it to you, you just need to substitute this formula here. A cap dagger of n is equal to root of n plus 1. If the state now becoming the same, then equal to 1, otherwise they will be equal to 0. Okay, so again you remember a cap of 0 equal to 0, and a cap dagger of 0 equal to a cap of 1, which is equal to 0 state. Okay, this is just some terms which you might be encounter after you solve that problems. And again, 0 operator state 2 equal to 0. So therefore you have 0 x cap square 0 is equal to h cross y by 2 m omega. How do you do this? How do you do these problems? You just need to operate this one. Use the above formula. Okay, a cap dagger. This one also do the same thing. This so in this case, what you need to operate is that you first operate a cap on the state 0, then after that you operate a cap dagger again on whatever state you get. Okay, so this is a pretty straightforward, and then the first term will goes to 0. Okay, the second term also will go to 0. The third term, this is very important because it will not be equal to 0, because a cap dagger of 0 will you will get 1, but a cap of 1 you will get 0. So these 0 and the end of your 0, that's 0 state is the same, right? So it will be equal to, you will get 0 0 state plus the last term will equal to 0. Now this 0 0 this equal to 1, it's not equal to 0. So that is why your final value will be simply h cross 1 by 2 m omega. Okay, so this is the expectation value of your x square. Now similarly for your expectation value of your p square, expectation value of your p square, how do we get the expectation value of your p square? So sorry, not simply p square, you get the expectation value of 0 p cap square and 0. Again you have to find this expectation value. So then you do the same thing. First, p cap square is equal to what? It's equal to minus m omega h square divided by 2. You just need to multiply again p cap into p cap. Okay, so you will get a cap dagger minus of a cap whole square. Then do the same thing. This will be equal to minus of m omega h cross divided by 2, and then we'll get a cap dagger square minus of a cap dagger into a cap. You just expand this and get minus a cap into a cap dagger plus a cap square. Okay, and here now 0 p cap square 0, what will happen? You will get minus of m omega h cross divided by 2. Again, what you will have to do is that you will need to extend again this one. You just need to put 0, right, and then this term here, and then again 0. Okay, then you do the same thing like we do in the x cap square. You will get something like minus of m omega h cross over by 2. Okay, and you'll get 0 again and minus of 0. The last time again you will get 0 0 and then plus 0. You will get more or less is the same fashion. So now 0 0 again, this equal to 1. If it is 0 and 1, then equal to 0. Okay, otherwise if it is 1 1, then it will equal to 1. Otherwise if they are different, then it will be equal to 0. Now what will happen? This is negative sign, this is negative sign, so you will get m omega h cross over by 2. Okay, simple. So now if I want to write solution, I mean not solution, the final answer, what happened? Expectation value of 0 x expectation value of 0 equal to 0. This is what we find. Expectation value of p, this is also equal to 0. Next, expectation value of x cap square 0 will be equal to, this is obtained to you, h cross by 2m omega, h cross by 2m omega, and finally 0 p cap square 0 equal to m omega h cross by 2. Okay, so the first set of the questions is done. They ask you to find what is the expectation value of x, expectation value of momentum, and p, what is the expectation of the square of the x square, that is the position square, then the momentum square, and so on. Okay, so these 4 expectation value is done. Now another set that questions asks is calculate the uncertainty del x and del p. Okay, so it is given that del a, in general form, del a is equal to expectation of a square minus of a square expectation value. Oh, sorry, not a, it is the other way around. A square expectation value minus of a expectation value of square. So now del x is equal to what? It is x square expectation value minus of x expectation value square, which is equal to what? X square we already know, h cross by 2m omega, h cross by 2 m omega minus this expectation value is 0 square, which is equal to simply h cross by 2 m omega. This 0 is again the expectation value of x, right? The expectation value of x equal to 0. That is why you get 0 into, even though if you square it, it is always equal to 0. Similarly, del p is also equal to what? P square expectation value minus of expectation of value of p whole square, okay, which is the same thing as p square is given to, we got to m omega h cross by 2, which is equal to m omega h cross by 2, and minus expectation of p is anyway equal to 0. Now you just need to multiplication del x dot del p. So del x dot del p equal to, what is the value of del x? Del x is h cross by 2 m omega, del p is m omega h cross by 2, right? So m omega and m omega will get cancelled, so you will get the value h cross by 2. So this is del x del p. Okay, so the last question of your week 4 assignments is done. Okay, so these questions is pretty like algebraic expression where you have to solve solve mostly like a standard calculation, which is not that much difficult, but you just need to know how to solve the problems, or some specific terms like what will happen if you operate state, what will happen if operate an operator a cap on the state n and a cap dagger on the state n, and what is the position operator, what is the momentum operator. And once you know this, this is a pretty straight and forward calculation. Okay, so what more which I have not finished last week is the questions number 4 of the same assignment, because if you look at the week 4, I finished till your this transition lines. You remember these transition lines where we have a Zeeman effect and so on, and in the last week we have Zeeman effect, anomalous Zeeman effect, and we calculate how many transition lines are there. So the question number 4 is of last week was instead asking you to solve what happens to the transition lines when it is exposed to electric field. That means you introduce perturbation. In this case, we have not talked about the time dependent. We are talking about the time independent perturbation. Okay, so question number 4 is that study the effect of an external uniform weak magnetic field which is directed, that means which is applied along positive z axis, okay, given by this much, okay, on the ground state, I think ground state of an atom. Okay, calculate the first and second order energy shift, okay, by perturbation theory. So what happens is that you remember all in the last class also we talk about every time perturbation we have to solve the energy correction terms, right? Energy correction terms, but in this case the potential is electric field, okay, which is given, that is the perturbation is given by the electric field, weak electric field I would like to say, and you have to solve the ground state of a hydrogen atom. Okay, suppose if you expose a hydrogen atom to a very weak electric field, so you will not get simply the unperturbed energy, so you have to also add up the perturbation corrections, okay, like we have seen in the last class. So it's the same thing. So what happens is that what do we call it? Suppose if we expose an electric field to the energy level of an atom, this is called as a Stark effect. But if you're exposed to a magnetic field, you call it as a Zeeman effect. Like last class we talked about the Zeeman. Last class we talked about the Zeeman effect. But now what happens that when you expose your hydrogen, could be your hydrogen atoms, or could be any atom which is related to electric field, then this effect is called as a Stark effect. Okay. So before we do that, again, you write out what is the unperturbed Hamiltonian. Right? Unperturbed Hamiltonian is given to you by H naught cap, which is equal to P square by 2 is P square by 2m, but it is here mu is called as a reduced mass, E square by R. Okay, this is a potential which we already have seen. Okay, this is the unperturbed potential. Okay, whatever we saw in the last few classes. Now what happens that perturbed Hamiltonian, oh sorry, before this let me write the eigenfunction. The eigenfunction of R, okay, this is a cylindrical polar coordinates problem, R theta phi operate on the state LFN, which will become to, which also equal to psi and Lm, right, of R theta phi. What will happen? The eigenfunctions will be equal to R and L, okay, YLM theta phi, right? That we have seen it. Suppose if you have a cylindrical polar coordinates problems, and what you need to do, you have to solve what is the radial function, and you also have to talk what is the theta and phi function. Okay, for any, could be a harmonic oscillator, could be a hydrogen atom, it's the same thing. We have to solve these three variables. These three variables like R, theta, and phi. Okay, so now this is for the unperturbed Hamiltonian. But when you apply perturbed Hamiltonian, will be what? HP is given to be E electric field into the distance, which is equal to E Z, because the electric field is applied in the Z direction. Now, so now let's solve the main energy correction. So E100. Okay, this is your ground state, because n is equal to 1, L is equal to 0, m equal to 0. This is your first ground state. It's given to be E100 plus, remember we have to introduce the first order correction terms, which is equal to E electric field 100 Z cap 100. How do I get this one? I just substitute this equation and then operate on the state 00. This is the first order correction term. And the second order, if you look back, I have already written the formula for the second order correction also. That means it's just simply the square of it. E square summation of n Lm not equal to 0, n Lm Z cap 100 whole square by E100 minus of E n Lm of 0. Okay, this is your correction term. Okay, but how do we have to solve the second term and we have to solve the third term, because this is the first order correction, this is the second order correction. Okay, so the second term, first we'll solve the second term. Okay, first we'll solve the second term. The second term was given to you 100 Z cap of 100. What will happen? This is also equal to your if you want to convert into an integration, you will get something like psi 100. Okay, and this will be square Z into d cubed R. Okay, if you want to convert into a 3D integration, you will get psi 1 square, and then Z is coming from here. Okay, and this term anyway is equal to 0. You don't need to do. So that means your ground state hydrogen atom, okay, the ground state hydrogen atom does not, the first order correction term is 0. The first order correction term for a hydrogen atom is 0. That means this term goes to 0. So what you need to do is you need to find out only the second order correction term, because the first order correction term is already equal to 0. That means we need to solve the second order correction term. Okay, so for the second order correction term, that means your del E is simply, that is, this is the correction term, is simply e square, right, summation of NLM not equal to 100, sorry, this is 100, and NLM z cap 100 whole square E1000 minus of E and LM0. For okay, for those who just joined just now, okay, let me just repeat. The first question I solved was from the last week. Two questions which I haven't finished last week. So the first was the fifth questions, which is related to harmonic oscillator, in which we have to find out what is the expectation value of x, expectation value of p, expectation of x square, and expectation value of p square, and also we have to find del x dot del p. Okay, so this is a pretty straightforward. I will also upload this notes in the drive. You can have a look. Okay, the second is question number 4, in which is a perturbation theory again, where a hydrogen atom is exposed or is subjected to a weak electric field given by this equation along the z direction. So instead of simply getting an energy term which you already know for a hydrogen atom, it will not be like that, because there will be a dependence on the electric field. This electric field is very weak, which is called as a perturbation. Okay, so for that we need to solve what is the correction term for the energy state of a hydrogen atom. The first correction term, first order, is equal to 0. Okay, that means for a hydrogen atom there is no first order correction term, but instead you will have only the second order correction term. Okay, that means which is given by this term. Okay, this is the second order correction term. Now in that questions it's also asks you to calculate, find the approximate value of polarizability alpha for hydrogen atom. Okay, that means polarizability is given by alpha is equal to minus of 2 delta E by electric field square. Okay, this is electric field. Okay, this delta E is energy. Okay, I have just make sure that this is epsilon. Let me make sure that this is epsilon, which is electric field, but this capital letter E is the energy term. Okay, so what happens is that when we solve, what happens is your alpha purely depends on delta E. Your delta E is given by this equation. Okay, and the only option is that here your n should be greater than 2, because n cannot be equal to 100, then n is equal to 1, n is equal to 2, n is equal to 3 for a hydrogen atom. So the value of n can be greater or equal to 2. Okay, so if you want to find out, alpha is equal to minus of 2 E square, because the electric field square and electric field square will get cancelled, so you will get minus of 2 E square summation of NLM not equal to 100, so you will get NLM again z cap 100, okay, square E100, this is the 0 order correction term, and E and LM. Okay, so what will happen now? Now you just need to solve only this term and you will get the value of lambda alpha. So what happens is that here, since n is greater or equal to 2, okay, we can write E100, that is the denominator term. Okay, we are talking about the denominator. E and LM 0 is less or equal to E100 minus of E200, and if you use the energy, En is equal to minus of E square divided by 2a naught n square. This is a long time back from your Bohr's theory, right? En is equal to minus of mz square e to the power 4, but it is just represented in terms of a e naught, where e naught is the Bohr's radius, is equal to E square by 2a naught minus 1 plus 1 by 4 equal to minus of 3e square by a naught. That means this term is, that means what I can say is that alpha alpha is less or equal to, so these two here and these three here will get multiplied. Okay, so you'll get 16 a naught by 3 NLM not equal to 100 NLM z cap 100. Okay, because your denominator, is less than 3e square by 8a naught. Okay, now we just need to solve only this term. So this term will be equal to what? Summation of NLM not equal to 100, okay, NLM z cap of 100 whole square. So how do we solve this? We can just assume that all NLM z cap 100 whole square, we can write this problem into this way: 100 z cap, okay, and then all NLM z cap into 100. We can write this one into this way. Okay, so at the end you will get what? 100 z cap square 100. So you just need to solve this equation, which is equal to 100 z cap square 100, which is equal to, again, this is z cap square, right? So you'll get, what happens, you'll get integration from 0 to infinity of r to r square cos square theta, right? R equal to 1. Okay, this we get it from your r theta r. Okay, now r theta and phi expressions. Okay, we get 0 to pi of sine theta d theta, but there is also a cos square theta term because this is z is equal to r cos of theta, right? Then finally 0 to 2 pi of d phi, which is equal to, again, 1 by 4 pi, this way. So how do I get this problem? Okay, how do I get, let me just remind you this one. How do I get this one? You just need to substitute r cos of theta, and you know the value of 100, right? You know the value, or you know the wave function of the 100. That means r of 10 square, and also what happens, you will also have cos of square theta, because here we got r cos of theta, and here d phi remain the same. So now you know what is the value of r10 square, and then you will get this equation to a naught square. You can solve this. Okay, you can substitute what is the r1 and the 0. Okay, that I have already given to you last class. What is the value of hydrogen for r10? We just need to put in square, and then integration from 0 to infinity, you will get I naught in terms of a naught square. Then therefore alpha is equal to what? Is less or equal to, this is 16 a naught by 3, 16 a naught divided by 3 into this term also will be here, a naught square will be equal to less or equal to 16 a naught cubed by 3. Okay, if you have any questions, you can still go to this books, this Zli books. There is a problems here, which is if let me just have a look. Yeah, I think this is related to your Stark effect, Fine-Struction and anomalous demand effect, and yeah, you can have a look. There is a problem which is related to your Stark effect. Okay, so in this chapter, if I'm not wrong, it will be in this chapter. Okay, in the chapter 9 you can have a look, and then there is also a solve questions there, which is related to your Stark effect. Okay, or I think it is in this solve problems. Okay, you go back there if you don't understand whatever I'm doing here. But the idea is that, how do you solve the problem? You solve the problems by solving the first correction and the second order correction. The first order correction is simple. You just integrate whatever the formula that is given to you, and the second order integration also, the formula is already given to you. You just need to perform the calculation. Okay, there is nothing big in it that you have to assume something. No, there is nothing like that. You just need to solve the first order correction and the second order correction, and then add to your original term. Okay, without the perturbation, you have your original energies, and when you introduce perturbation, you have both the first order correction term, second order correction term, and so on. Okay, so in this question it asks only the first order and the second order. That is what you have solved this one. This is your second order correction term, because your first order correction term is equal to 0. Then they also ask about the polarizability, and polarizability depends upon your delta E here. That is why you solve this alpha, which is approximate less or equal to 16 A naught cube by 3. Okay, so now your week 4 assignment I have done. Okay, your week 4 assignment is done. Now we will go to your week 5 assignment. So in your week 5 assignment, what happens is that there are two things. One is your variation method. One is your variation method, and second is your time dependent perturbation. Time dependent perturbation. Okay, so we will first see what happens to your variation method. Okay, what happens to the variation method. So till now, what happens that we have solved only original Hamiltonian, that is without the perturbation. We also have solved Hamiltonian with perturbation, that is the time dependent perturbation. Third, this is a variation method. Why this variation method? And its variation method is another, I would say, is another techniques in which you solve a Hamiltonian, in which you cannot solve easily by your original method, which you already have done in the first two last two 1 or 2 classes. Okay, so that means I would rather say some problems, I would say some problems cannot be solved exactly by perturbation theory. Okay, there may be problems in which you cannot be solved directly by perturbation theory. Okay, so what do you do? Okay, what is the difference? Because in normal cases, what do you solve? You solve the Hamiltonian H psi and you get the energy psi. This is what we have been doing all along, right? You solve the Hamiltonian, it's given to you p squared by 2m plus the potential, and you solve the potential, you will get the energy term, right? This is what we have been doing all along. But what happened in your variational method? In your variation method, you solve delta E psi equal to 0. You don't solve directly your Hamiltonian, but you solve in the variation delta E equal to 0. That is the minima or your maxima, where E is simply given to you by your expectation value. Okay, here you don't solve directly the Hamiltonian, but you solve your delta E psi equal to 0. That means the minimum value of E psi, that means from here, the minimum, whatever the minimum value of E psi that you got, provides an upper limit approximation for the true energy of the system. Okay, that means you can find what is the minimum energy from your delta E psi. Okay, we will see how do we solve it. But this idea is that it's not, we don't solve directly the Schrödinger equation, but instead we assume a wave functions, and then we solve what is the minimum value that the energy, the minimum possible value of energy. And this is useful to determine ground state system. Okay, this is useful to determine ground state system. So if we have to solve, how do you do method? I'm just giving you how many. If a problem is given, how do you solve it? First one, guess the trial wave function. Second, calculate energy. This energy is actually in function of some alpha term. Okay, this energy is a function of some constant term alpha. Third, search for minimum value of E, let's say alpha 1, alpha 2, and so on, which is a parameters. 4. Substitute alpha to obtain approximate value of energy. Okay, so what you need to do, you have to first guess a trial wave function. In most of the cases, it is given to you a trial wave function. Then what you have to calculate the energy in terms of alpha. Then you have to find out what is the minimum value of E naught or of E naught, and then substitute back for those minimum value of E naught, you will have an alpha value. Okay, because E naught, it depends upon your parameters alpha. So for the minimum value of E naught, you will have alpha value, and substituting back that alpha value in your energy term, you will get what is your approximate energy. So that is the question number 1. Let's look at it, so that you will becoming you can be clear. What happens is that a trial wave function is given to you, a alpha square minus of x square whole square, where x is less or equal to, and 0, x is less or equal to infinity. Okay, so here a is your normalization constant. Okay, so we will follow the rules that we have just added. First of all, you write out what is the Hamiltonian. Hamiltonian is equal to what? Minus of h cross square by 2m, right? That is p square by 2m, d square by dx square, plus the potential is half m omega square x square. So how do we get this? Is p square by 2m actually, right? This term is actually p square by 2m, but p is equal to I h cross del by del x. So I square is equal to minus 1. Okay, now, so what does this variation principle? Let me write the variation principle. The variation principle states that the expectation value of E, which is a function of some parameters alpha, for a trial function psi of x, that means it's given to you trial function, that the expectation value of the energy, the expectation value of E, which is a function of alpha, provides an upper bound to the ground state energy E naught. So what does it mean? Whatever the expectation value that you got from this trial wave function is actually the upper bound of your ground state energy E naught. Okay, so that means, that's what I was saying, that it's helping in determining the ground state energy, because whatever the expectation value you get, that is the upper bound of the ground state energy. So E to the power of alpha is equal to what? Expectation value is psi h cap of psi. Okay, so now what we have to do, step 1, wave function is given to you, and in such a way that wave function psi of x is equal to a, right? And a of x square minus alpha square minus x square, alpha square minus of x square. But what we have to do, we have to normalize first, such that we will get the constant a, right? So what happens, normalization condition is psi star psi dx is equal to 1. So we get something, psi star psi means a square and alpha square minus of x square to the power 4 dx equal to 1. We have used this formula, so simply like psi star psi dx equal to 1. Okay, this is the normalization condition that we have done long time back. Now if you evaluate this term, simply this term, integration from minus alpha to plus alpha, alpha square minus of x square to the power 4 dx, what happens? You get a very long term, something like to integration from 0 to alpha to the power 8. You just need to expand this one, alpha 8 minus of 4 alpha 6 x square plus 6 x to the alpha 4 x to the power 4 minus of 6 alpha square x to the power 6 plus x to the power 8 dx. Okay, if I made a mistake, you can point it out, but you can try to expand this term and then check whether whatever I have written is there any mistakes or not. Okay, I will also upload these notes which I have solved with me. Okay, you can check and you can have a look at it. So now what happens that if you evaluate, you'll get 2 5 6 alpha to the power 9 by 315. Okay, that means only this term you will get 256 alpha to the power 9 315. That means what happens, integration from minus of infinity of a square into 2 sorry a square into 256 315 alpha to the power 9 equal to 1, right? If we substitute back in this equation, in the first equation, then you will get a square equal to 315 256 alpha to the power 9. Okay, so that means you got what is your value of a square. Okay, so now a square is done, your normalization. Now second step, what you have to do, we have if you remember correctly, what is the rule? First you have to guess the trial wave function. That is already given to you. What we need to find here is just normalization. In this step, since the wave function is already given to you, you just normalize. Second is you have to calculate the energy term, right? The expectation value of your energy term. And what is the expectation value of energy term? Your expectation value of energy term, it consists of kinetic energy plus your potential energy, right? Now T is what? Your kinetic energy is h cross square by 2m integration from minus alpha to plus alpha d psi by dx whole square dx. How do I get this one? You go back to this one, to the first term here, this one. Your first term is in fact kinetic energy. Okay, the first term is in fact kinetic energy. So you just need to find out the expectation value of T. Here we assume what is the wave function. Okay, you find out what is the energy, which is kinetic energy plus the potential energy, and you find out the expectation value of that. So this h cross square by 2m we got by substituting it from your main equation. Now d psi by dx again, d psi by dx, what is the value of psi? Psi again is already given to you. This equation, psi is already given to you, a alpha square minus of x square whole square. So I'll just write d psi by dx is in fact minus of 4a x alpha square minus of x square. Just differentiate it, okay, and then square it from minus alpha to plus alpha d psi by dx whole square dx. Perform the integration, you'll get minus of alpha to plus alpha 16 a square x square alpha square minus of x square dx. Well, what did I do here? I just square root this one and then put it into the integration. Why do you need this integration? Because you look at it, you see d psi by dx whole square is there in your calculation to find out the expectation value of your kinetic energy T. And again, this is equal to what? This is equal to 256 by 105 a square alpha to the power 7. And now you also need psi, which is equal to 256 by 315 a square alpha to the power 9. Okay, so how do you get psi? Again, you have to just integrate psi, integrate it, you get psi star psi, and you put the value of this psi, which is already given to you here. Sorry, where is it? Yeah, psi is already given to you, and you put the value of a square also. A square you already got here. This term here, what is a square value? Yeah, a square also you got the term, and you can just substitute it. So first you find out the normalization constant, then you find out the expectation value of your kinetic energy, and you find out the expectation of kinetic energy, which is equal to what? Now h cross square by 2m and then 315 by 105 alpha square. How do I get this? You can take this one as your main equation. You can take this one as your main equation, equation 1, that is your kinetic energy, and you solve first d psi by dx whole square integration of dx. First you solve first this term. This is what I got in here, equation 2, right? And then I solve the third term, this one, psi. This is what I got, this equation 3. Then you can substitute 2 and 3 in 1, you get this one, kinetic energy. So simply, if you 3h cross square divided by 2m alpha square. Okay, so from here you get what is your kinetic energy. Now what is the next case? The next case, the third one, you got the kinetic energy, but you have to find out the expectation value also, expectation value of your potential also, which is given to what? Half m omega square. If you look back in your what is expectation value for your this one, for your potential, is half of m omega square x square. So you do the same thing, half of m omega square x square, integration from minus alpha to plus of alpha, you have x square psi square dx by psi. Yeah, here also you do the same thing. Okay, so first you perform this, let's say the first integration. First, let's say you perform this integration, which is equal to minus of alpha to plus of alpha x square psi square. Anyway, you already know, x square minus of alpha square minus of x square to the power 4 d of x. If you solve this again, it's the same thing. You will get 256 by 3465 alpha to the power 11. Then psi also you already know. Then expectation value of v will be equal to half of m omega square, expectation value into x square. You will get 256 alpha to the power 11 by 3465 and divided by psi, right? So psi is equal to 256 by 315 alpha to the power 9. And how do you get psi? It's already given here. Yeah, this term. Okay, alpha. And what is the value of a square? A square you already know, you have already solved, and you can just substitute the value of a square also. Then finally you will get m omega square alpha square by 22. Okay, so the idea is that first you take the trial wave function and you write the Hamiltonian of it, which is simply kinetic energy plus potential energy. And then what you can do is that you can just find out what is the expectation value of the kinetic energy and the potential energy. Okay, so that is the second steps. Now if you look carefully, now you get the energy expectation value of energy, which is equal to kinetic energy plus potential energy. You put what is the value, you will get 3h cross square by 2m alpha square plus m omega square alpha square by 22. This is what we have just solved, right? What is the expectation value for your kinetic energy and what is the expectation value for your potential energy. And now that is where it comes here. The fourth step or the third step, let me just look at it. The third step is, yeah, the third step, we are talking about the third step, search for a minimum value. How do we search for the minimum value? You already have the expectation value of E. So let me write here the third. Here this is still second. Okay, this is still second steps here actually. This is still second steps. You are still finding what is the expectation value for both kinetic energy and for both potential energy. Now you are talking about the third steps, which is how to search the minimum. So simply you already know the value of energy, and what you need just to how to find out the minimum. You just differentiate dE divided by where? dE with whom? dE with d alpha. Because why? Your energy depends on your alpha term. dE divided by d alpha equal to 0. Okay, this is a condition where you can do. Then you just differentiate dE by d alpha. In both the second term, you will get minus of 3h cross square divided by m alpha cube plus m omega square alpha by 11, because ideally you will get 2m omega square alpha, but this is 22, so 2 and 22 will get cancelled and you will get equal to 0. Now what you can do, you can find out what is the value of your alpha. So minus of 3h cross square by m alpha cube equal to m omega square alpha by 11, and you carry alpha together, you will get alpha 4 equal to 33 h cross square by m square omega square, and alpha is equal to 33 h cross square by m square omega square to the power 1 by 4. Right now you got the value of alpha. This is the third step. That means we have find the minimum energy value of E, in which alpha is this one. Okay, so how do we find out the total energy? You can just substitute back in your energy. So energy minimum is this term. You take this one, I have named this equation 3, so let's name this one as equation 4. So from equation 4, E minimum is equal to, you just substitute whatever value of alpha, we just substitute with this equation. So you will get what? 3h cross square by 2m, and then instead of alpha square, you substitute with this term. Remember, this is alpha to the power 4. Okay, so if you put alpha square, then you will get a square root on the other side. Okay, you will get m omega by 33 h cross plus m omega square by 22. You will get root over of 33 h cross by m omega, and then you just evaluated this first term and second term. You will get root over of 33 by 11 h cross omega. This is your E minimum. Okay, so what did we do in the first step? This is your final answer. Okay, how do we do this? Remember that we assume a wave function and we normalize it. So that is the first steps. Once you have a wave function, remember you have to normalize it. The first condition. Second is that you have to find out what is the expectation value. And here, what do you find out the expectation? Kinetic energy and potential energy. And we know that the total energy is kinetic energy plus potential energy. So if you know the expectation value of your kinetic energy and the potential energy, you know what is the expectation value of your total energy. But these expectation value of total energy depends upon the value of your alpha term. That's what we have seen, alpha. So how do we find out? You have to find out what's the value of alpha. To find the value of alpha, what you need to do is that dE by d alpha equal to 0. That is the condition to search for the minimum energy term. Okay, so once you get the value of alpha, you substitute back in the main equation of the energy term, you will get this total, you will get the final result. Okay, so if you follow these 4 steps, that means first wave function, then find the expectation value of energy, then search for the minimum moment of energy by differentiating dE by d alpha or dE by any constant parameters, and you will get back what is the value of alpha, and then substitute back this value of alpha in your main equation energy. So yeah, so this is a substitute 4 and this is 5. So substitute 4 in 5, you will get what is the minimum energy. Remember, this is the minimum energy. Why? It's because you are using this condition dE by d alpha equal to 0 to find the value of alpha term. Okay, so I hope this is clear to you. Okay, so now the next case which I will be solving, so maybe one more problems I can solve, is related to your time dependent perturbation. Okay, so till now we have solved, we have seen perturbation. What perturbation is? Time independent. Okay, that means it does not depend upon time, and we have solved the first order correction, the second order correction also we have solved, and then we also have seen if we cannot solve exactly what are the other methods, you can use the variation method. Okay, there's also a method too, that is also the same thing to find out what is the energy. Okay, in most of the cases we find out what is the energy, and in the variation method what happens that it is most useful to find out the ground state energy. Okay, now what happens if your perturbation potential is time dependent? That means it's changing with time. Okay, so what happens is that ideally means your H is equal to H naught. This is the unperturbed Hamiltonian plus V of t. You see, this perturbation potential here is a function of that t. So H naught is time independent That means it does not depend on time, whatever you get it. But v of t is time dependent. Okay, so that is why this psi of t here becomes important. So what does it mean? How does v of t affect the system? Okay, so that is the question. How does v of this is v cap of t? How does v of t affect the systems? Okay, what is the difference? Okay, so so ideally I can see, okay, this is again from your main quantum mechanics, which says that when a system interacts with a potential v of t, it either absorb or emit energy. Okay, the systems can either absorb or emit energy after interacting with the potential v of t. So the process causes the system to undergo transition. That means it will go on transition from one unperturbed eigenstate to another. So what does it mean? So suppose you have a system which is unperturbed. Okay, that means it's your original Hamiltonian. Now, or a systems. Now you introduce a little of time perturbative potential v of t. What happens is that because of this time dependent, the systems can either absorb or emit energy. That means it can go from one state or one unperturbed eigenstate to another. That means there is a transition from one state to the other states. So what is the question that you are talking about? What is the probability that your system can transit from one state to the other state? So what is the transition probability? You remember, we are talking about the transition probability. What is the probability that the system will change? Okay, so the transition probability from an initial unperturbed, which is given by psi I, to another unperturbed, which is given by psi f. That means that means the system undergo from initial state psi I to another state psi f, because of your potential v of t is given by probability from initial state to the final state is equal to psi f, that is the final state, plus I can write it here, is given to minus of I divided by h cross integration from 0 to t and your final state psi of f and your perturbation t prime and psi of I, your initial state, e to the power of I omega fi t prime dt prime. This is slightly a long derivation, not a long derivation, it's slightly a long equation, and omega fi is equal to ef minus of ei by h cross. So that means, you see, there is a final state here, there is an initial state here, there's a time perturbation potential here, and this e omega is actually the energy difference between your excited state and your ground state, or your first state and the second state. Okay, so I hope you understand this equation. That means when you introduce a perturbation at time dependent, in the other words, you can say that there is a transition probability of the system from one initial state to the final state. Okay, so the question number 2 of your assignment, it talks about what? Question number 2, it talks about a particle of mass m in the ground state of a 1D harmonic oscillator. That means you have a 1D harmonic oscillator you have a 1D harmonic oscillator, and it is in your ground state, is placed in a perturbation potential V of t equal to minus of V naught x cap e to the power minus of t by tau. You see, now your perturbative potential, it depends upon the time t. Okay, so you consider that there is a harmonic oscillator and the system is in the ground state, and you have your time perturbation potential V of t. Okay, so what happens is that calculate the transition probability of finding the particle in the first excited state after a long time. Okay, so that is the question. The question is, find the transition probability from your ground state, okay, whatever you have ground state, to your first excited state. Okay, so this is exactly the equation which I have just given you just now. That means initial state of the system is at the ground state, and you find out what is the probability that the system will go from the ground state to the first excited state because of this potential V of t. Okay, so A, your transition probability will be what? PIF, I have just given it just now, 1 by I of h cross, and integration from 0 to t. Okay, instead of psi f, I can write just simply f, which is the final state, and V of t prime, get I e to the power of I omega f I t prime dt prime whole square. Okay, so now the first is, you know, where energy of a harmonic oscillator is n plus half h cross omega, right? That is that is two class. We saw what is the energy of a harmonic oscillator. And now for the ground state, this is n equal to 0, right? It will be simply half h cross omega. And for the first excited state, that means you put n equal to 1 here, we get 3 by 2 h cross omega. So what is E10? Because EFI here means what? Omega Fi means what? Is related to energy between the first and the ground state. So E10 means E1 minus of E0 by h cross will be simply omega. That means you substitute what is the value of E1 from here. E1 you get it from here, and E0 you get it from here, you get E10. This is the energy difference between your first excited state and your ground state. Now, so this term you already know, omega Fi you already know, okay, which is equal to this term, omega, okay, which is equal to E1 minus of E0 divided by h cross. Okay, now you need to solve this term. This term is what? Is f v cap of I, which is equal to, you know, the first you know the final state is equal to 1. You know the first excited state, right? You get 1, and then we get v cap, and you know that the ground state is 0, and V of t is in fact minus V naught x e to the power minus of t by tau. This is already there with you. Okay, now how do we solve it? So 1 V cap of t0 is equal to what? Is equal to 1, and then V cap you substitute with this, you get minus of V naught, and then x cap e to the power minus of t by tau 0, and then you take it out, this term which is not required, we get minus of V naught e to the power minus of t by tau, and then you get what? 1 x cap of 0. Okay, so what happens is that from here you see that there is an x cap term here. So remember, for a harmonic oscillator, just the first question that we solved today is equal to what? Is equal to h cross by 2m omega a cap plus a cap dagger. That is, you know, the fifth question that we have just solved in today's class, the first question that we have solved today's class. Then therefore 1 x cap of 0 will be equal to what? H cross by 2m omega, you get 1 a cap plus of a cap dagger of 0, and you know this will be equal to h cross by 2m omega, and this will be simply 1 1, because a cap of 0 will be equal to 0, but a cap dagger of 0 you will get root of n plus 1 n plus 1. You remember this one, right? So you will get simply h cross by 2m omega. That means if I zoom it out, what happens? You are trying to solve this equation. Let me just remind you this equation. Let me take this as equation 1. Let me take this as an equation number 2, and let me take this as equation number 3. So you put 3 in 2, what happens? You will get 1 v cap of 0 is minus of v naught e to the power minus of t by tau, and you substitute h cross by 2m omega. Okay, so now this term is also done. This term is also done. So omega is done. This first term is also done. Then the last time is you just need to do the integration p of if. So that means before I do the integration, I'll just solve 1 by I of h cross, integration from 0 to infinity, and 1 is given minus of v naught e to the power minus of t by tau. This is what you got, right? And then root over of h cross by 2m omega also you got, and e to the power minus of what? Sorry. So this is minus of v naught and e to the power minus of t prime by tau. Why I do it here? Because your integration is with respect to t, so you have to make sure that you are integrating according to this term. Okay, this equation, and e to the power of I, and instead of omega fi you already know omega, right? So omega t prime dt prime okay. Okay, so what will happen to this integration? We get minus, you can take minus v outside, and I h cross you can take it as it is, h cross you can take it also outside the integration, and you will get only 0 to infinity e to the power this term I omega minus of 1 by tau t prime dt prime. You take common t prime, you will get minus 1 by tau t prime. Okay, then you do the integration for this. What will happen is that you get minus of v naught by I h cross, okay, h cross by 2m omega, and then integration will be simply e to the power of I omega minus 1 by tau, and also I omega minus of 1 by tau from 0 to infinity. Okay, and if you do this, you will get, you just solve this equation, not equation, you just substitute the value of alpha and infinity. You will get something like h cross by 2m omega 1 divided by simply I omega minus 1 by tau. Okay, so what is the probability? This is simply under the term. Okay, I divided by h cross of this is simply this term, I h cross of this one. So now I first solved what is omega fi, then I solved this equation, the first equation, then I introduce all of them integration 0 to t, or 0 that means 0 to infinity. Then finally what? You can just square it on both sides. So the total probability will be square root of both. So that means probability of 0 to 1 will be equal to what? Square root of this. I mean square of this, not square root, square of this equation. I h cross by 2m omega 1 divided by I omega minus 1 by tau whole square. So it simply will be simply v naught square by h cross square, because I square is equal to minus 1, okay, and h cross by 2m omega, and this term is in fact 1 divided by omega square plus 1 by tau square. Okay, this is simply a minus of ib whole square. Okay, I can just write a minus of ib whole square, which is simply a square plus b square. Okay, then you will get v naught square by, okay, sorry, this also will be square term here, so will be simply 2m omega h cross, simply 1 divided by omega square plus 1 by tau square. So the final result will be v naught square tau square. That means you take tau square also up, we will get 2m omega h cross 1 plus omega square tau square. That means you just solve this equation. Okay, so if the idea of this problem is, if you introduce a perturbation which is a time dependent, how will you find the transition probability? If you want to find the transition probability, you just need to use only this formula, 1 by I divided by h cross integration from 0 to t, and you have what is the final state, you have the initial state, okay, and you also have omega fi, which is the energy difference between the first and the ground state, and you also have what is a time dependent perturbation. So in most of the cases, what happens, v of t is given to you. Okay, that means the potential is given to you, and what most of the cases, omega, which is the energy difference of the first excited and the second excited, is also unknown, because this is the time independent. Sorry. Now that this energy is obtained from your original Hamilton of the harmonic oscillator, which you don't introduce any perturbation. The only things that you need to do is you have to solve this equation. This is your addition term. What is the first state and the ground state, that you need to know, and you can just solve what is the value of v of t, and v of t is given to you here. So again, you just need to solve this integration, or not integration, you have to solve that this your first and the ground state, and finally you will put the integration and you square it. Okay, so that you will get what is your total total probability of transition from your ground state to your excited states. So that means, suppose if your energy here is half h cross omega by 2, right? This is half of h cross omega. This is your state which has 3 by 2 h cross omega, right? So what is the transition probability? This is your result. Okay, so that is what happens when you introduce a perturbation. There is a transition probability from your ground state to the first excited state. Okay, so I have 10 to 15 minutes more. Okay, so quickly I will solve one final problems. Okay, quickly I will solve one final, which is question number 3. Quickly, this is a little lengthy problems, but okay, I will also upload whatever I have solved, and you can have a look properly, because it's a little lengthy. Okay, so the idea is, consider a two-level system. Consider a two-level system with energy E1 is less than E2. Okay, this is given to you, and there is also a time dependent potential which is given to you, V11 equal to 0 equal to V22. V12 equal to gamma e to the of I omega t, and V21 is equal to gamma e to the of I omega t. This is the time dependent potential is given to you. Now, yes, at t equal to 0, okay, it is assumed that it is in the ground state, like we have assumed in the previous case. It is assumed to be in the ground state. That means only the ground state is populated. So that means at t is equal to 0, it's expected it's in ground state. That means your C2 of 0 is equal to 1, and C1 of 0 is equal to 1, and C2 of 0 equal to 0. This C1 and C2 are your constant terms. Okay, that means find C1, and C1 of t whole square and C2 of t whole square. And this is exactly a similar thing that we have done in the previous case. That means it is given to you two energy level state, two energy level state or systems in which the energy E1 is less than the energy E2. Okay, and also your potential is given to you. And what you need to do is that find this term C1 and C2t by solving coupled differential equations. Coupled differential equation. Okay, so the question is already there with you. Okay, I will not write this, it's lengthy. Now, first of all, to solve any equation, what you need to write is that you have to write first what is a coupled equations. What is equations? So that coupled equation is given by I h cross c k dot. This is the general equation, which is equal to summation n equal to 1. Since in this case it is it consists of two terms, you will get from n is equal to 1 to 2 v k n e to the power of I omega k n t c of n. Okay, this is your general equation. So now we can use to find c1 and c2. So I h cross c1 dot, which is equal to what? K is equal to what? N is equal to what? So you are talking about ICK. So which will be simply V1 2. Okay, which is there to you, right? It's because your we want to e to the power of I omega 1 2 t and c2. Okay, this is for the c1. Okay, I h cross c1 dot, and we want to e to the power of I omega 2 and c2. Okay, the question is what happens to your c1, right? Because this is your summation, so you have to take n is also equal to n is equal to 1, right? But in that case your equation is already equal to 0, so that is why you will get I h cross c1 dot is equal to v1 2 e to the power of I omega 2 t c2. Okay, so then you substitute what is the value of v12 is given to you from here. V12 is given to you, so you will get gamma e to the power of I omega t e to the power of I omega 1 2 t c2. Okay, and remember this omega 1 omega 2. Okay, I will write it later. Okay, this is your first equation, and then the second equation is what? I h cross c2 dot, which is equal to what? Which is equal to v21 e to the power of I omega 21 t c1, which is equal to gamma. Again you substitute what is the value of v21, which is equal to gamma e to the power of minus of I omega 2 e to the power of I omega 21 t c1. Okay, so if you solve both of them, you will get I h cross c1 dot equal to gamma. I mean that just solve this equation. You will get gamma e to the power of I omega minus of omega naught t c2, and I h cross c2 dot is equal to gamma e to the power of I omega minus of omega naught t c1. Okay, so what is omega naught here? Omega naught, we have assumed that omega is equal to omega naught is equal to omega 1 to 1 is equal to omega 1 2, which is the energy difference E2 minus of E1 divided by h cross. Like we have assumed previously, right, that there is an energy difference between your first excited state and your ground state, and that difference is given by omega naught. Okay, so now we also assume here, now let delta equal to omega minus of omega naught. This is a negative sign. Okay, so let omega minus omega, so that you can just substitute this one in terms of your delta. Now your c1 dot equal to minus, you can just substitute back this, we get minus of I divided by of h cross gamma e to the power of I delta 2 c2, right? And c2 dot will be equal to minus of I divided by h cross gamma e to the power minus of I delta t c1. So till now what we have assumed, till now what we have done is that we have just put what is the value of your main equation from your coupled differential equations. We write in terms of c1 and c2, and then we substitute what is your value of your potential v12 and v21. That's it. We have not solved anything. We have just substituted. Ideally we have just substituted. Now, so now in order to solve these two equations, what can you do? One thing is that you can take that second derivative of this. Take second derivative of this equation, of either one of them. I will take the c2. Okay, you can take the c1 also, it's the same thing. So that means c2 double dot, dot means dc2 by dt, double dot means d square c2 by dt. Okay, which is equal to minus of I gamma by h cross minus of I delta e to the power, that means if you take the derivative of this, e to the power minus of I delta t c1 plus of e to the power minus of I delta t c1 dot. Okay, so now you have c1 and c1 dot. So c1 dot, you substitute this one. C1 dot is already there with you, so substitute c1 is equal to I h cross divided by omega e to the power of I delta t c2, and c1 dot equal to minus of I gamma by h cross e to the power of I delta 2 c2. Okay, so how do you get c1? How do you get c1 and c2? Okay, how do you get how do you get this equation c1 and c1 dot? Okay, so c1 you can get it from here. That means you can substitute back everything in terms of c2 dot, and c1 dot you get everything in terms of your c2. So just substitute back. So what you will get? You get c2 double dot equal to minus of I gamma by h cross and minus of I delta e to the power minus of I delta t, and then you can substitute this equation I h cross by gamma e to the power of I delta t c2 dot. Okay, instead of your c1 you substitute this c1 term, and instead of your c1 you substitute this c1 dot. Okay, c1 dot you substitute with c1 dot plus e to the power minus of I delta t, and you will get minus of I gamma by h cross e to the power of I delta t c2. Okay, so here it looks confusing, but I have just substituted what is the value of c1 and c1 dot directly in your in your equation. Okay, it looks confusing, but just bear with me. Okay, just bear with me. Or if you have any confusion also, you can always look at the notes which I will be sharing with you, okay, in the drive. Then you can have a clear understanding. Now you just equate this equation. You will get minus of I gamma by h cross, then this equation it was I delta t, and this will goes equal to 1, so you get h cross delta by gamma c2 dot minus of I gamma by h cross c2. Okay, so if you look at this equation, what do you get? What do you see? You see this is the second derivative. You get d square c2 by dt square. This will be dc2 by dt. This will be c. This is simply what? This is simply c2 double dot plus I delta c2 dot plus gamma square h cross square c2 equal to 0. That means you substitute everything here. What is this? This is simply your differential equation, right? This is simply your differential equation. There is nothing different. This is simply your differential equation. So your differential equation is c2 double dot plus of I delta c2 dot plus your gamma square by h cross square c2, which is equal to 0. Now imagine you have two differential equations with two different types of variables that you have to solve, that is c1t and c2t. But what we do is that we equate one after the other, such that we get only, now you have only one variable to solve, c1 or c2t. Now we are going to solve only c2, and this is simply a differential equation. So what happens, that differential equation you can write simply as maybe something like some r, maybe some, shall I write r or something? Yeah, you can I can write r also, something like r equal to what? Characteristics equation. The characteristics equation of this will be equal to simply r square plus of I delta r plus gamma square by h cross square equal to 0. This is a, you can look this one to any mathematics books, differential equations. Okay, it's a simple differential order, second order differential equation, and your r is simply minus I delta plus minus b square minus 4ac 4 gamma square by h cross square by 2a. That means 2a is equal to 1. So this is a polynomial equations. Minus of I delta plus minus I delta square. So I square is equal to minus 1. So you don't need to do anything. You can write simply delta square. I, you can take it out, plus 4 gamma square by h cross square and by 2. So now you just substitute this one. So omega is something like root over of delta square plus 4 gamma square by h cross square. You can just substitute gamma, that is for easier. Otherwise you can just write the same thing. Okay, there is no harm in it. Okay, I just write it so that it will be easier. So r equal to minus of I or I would rather say I equal to uh, instead of that I will write the roots are equal to I minus delta plus omega by 2. Okay, that means it consists of your imaginary part as well as real part. So for imaginary part and real part, you know the solution for C to T. This is from the solutions R1 C to T is equal to e to the power minus of I delta T by 2 and A cos omega T by 2 plus B sine omega T by 2. How do I get this equation cos and sine? That you go back to differential equation. If the roots are real and imaginary, what will happen to the solution? You will have cos term and sine term. Okay, so that that you can have a look at. Okay, now so this is your C to T. This is your C to T. Okay, and it consists of your constant A and your constant B. So in order to do that, in order to solve any constant parameters, remember we always have to put boundary equations. If you want to solve any constant values, like any constant parameters, not constant, any constant parameters, you always have to use boundary equation. Long time back also we used to do that. We in the first and second class also. If you want to solve any constant, you have to always put a boundary condition. And in this case, what happened? The boundary condition from your question is already given at t equal to 0. What happens? C1 of 0 equal to 1. This is the boundary equations, and C2 of 0 equal to 0. Now you already know. So you just put here C2 of 0. Your C1 will be equal to 1 and t equal to 0. So t equal to 0, the second term will completely goes to vanish because sine and t equal to 0 is completely vanished. So C2 of 0. What is the term that is remaining? Cos. This is also equal to 1 and this is also equal to 1. You will get 0 and you remember A equal to 0. Okay. Now what is another boundary condition? C2 dot of 0. What happened to C2 dot? That means you just again differentiate this one. C2 dot is also equal to 0. C2 dot, which is equal to minus of I gamma by H cross C1 of 0. Okay, so that is also you differentiate C1 of 0. This is equation. I will name it as equation 6, equation 7. I'll name this one as equation 5 for you to be easier. And then let me just find it. And omega, let me just name it as equation 4 for you to be easier. And is there anything else? Yeah. So how do I get this? How do I get C1 dot? This is from 3. Okay, you just need to differentiate C2 0. You will get this equation. Now from there, what happens? C2 dot, you will get something like from 5. That means from this equation, from 5 you differentiate C2 dot of 0. You will get B omega by 2 equal to minus of I gamma divided by H cross, which will be simply B equal to minus of 2 I gamma by H cross omega. Okay, so that is done, more or less is done. So if you want to solve the constant parameters, first of all you look at the boundary condition. So boundary condition is already given to you in this case, and the second boundary condition you just differentiate the value of C2 dot equal to 0, which is also equal to 0. Okay, that is also important. Now therefore amplitude C to T. What happens to the amplitude C to T? Now you know what is the constant A, you know what is the value of the constant B. You can just substitute it in that equation. You will get e to the power minus of I delta T by 2 I gamma by H cross omega sine omega T by 2. Okay, so this is after substituting what is the value of A and B in your equation number 5. Okay, substitute the value of A, you know, from 6, B also you know. Let's say from 8, I will rather name 8, and you substitute the value 6 and 8 in 5, you get what is the value of your amplitude. Now what is the probability? Probability is simply C2 square. That means you just have to square this term. It will be simply 2 gamma by H cross omega whole square, right? And then sine square omega T by 2. Okay, so that is if you want to convert back this delta, you can convert back, because delta we have assumed to be delta square plus 4 gamma square by h cross square. If you want to convert, if you don't want also, it's fine, as long as you make sure that you mention that what is the value of omega. Omega is delta square plus 4 gamma square by h cross square. Okay, and that is done. So the question, we need to find c1 square and c2 square. So c2 square we already got, and what how do we get c1 square? Easy. You use the condition, c1 square plus c2 square equal to 1. Then c1 square is simply 1 minus of c2 oh whole square. Simply, I think 1 minus c2 square. So sorry. Okay, which is simply 1 minus of 2 gamma, and then by h cross omega whole square sine square omega t by 2. Okay, so if you look at it, how do you solve the value of c1 and c2 square, which is the probability? First, you can in the first case we solve what is the perturbative. Okay, in the first case we solve what is the v of t. Here v of t is also given to you, is similar problems. V of t, if you look back, v of t is given to you with gamma e to the of I omega t plus gamma e to the of I omega t. Okay, so once you solve that, you can just square it, the amplitude, then you will get what is the transition probability. So I will also upload whatever I have written in my notes, okay, to the drive, and you can have a look at it much more detailed if you need time. If you have any questions, you can always ask me anytime. Okay, so I will stop here for today, and maybe next class we will be next week I think it will be related to your electrodynamics. I think quantum mechanics is I think it ends here. Okay, maybe 1 or 2 more questions is there. I will be solving next week for your week 5 assignment. Otherwise, we will move to electrodynamics if I'm not wrong. Then yeah, so thank you for joining the class, and maybe I'll see you next week. Okay, thank you so much.